Hey there, welcome back. In this clip, we're going to take a look at one more symbol that's used to structure formulas, and then we will talk about order of operation and explore a couple of fancier, more uh, complex formulas. Okay, so here we go. This is all built likely on concepts that you're learning in math. So hopefully, it's just a refresher or reinforcement. If it's an introduction, you're probably going to want to get some help from me just so that we can make sure that you've got the basics with the math. Otherwise, this could be really frustrating for you. But hang in there. It's possible. It's not super difficult. You just need to make sure you understand the basics here. Okay, so we have parentheses, which are both of these, and most of you know how to use them. I'm just going to break them down into two parts so that you're clear how I will be referring to them. So I will call the left-hand parenthesis the open parentheses, and the right-hand parentheses, I will call it the close parentheses. Okay? So here on out, they will always go together. This is always representing the left side and the right side. So imagine, right, that you're creating a little box. Oops. What goes in between is the contents of the box, or what's inside the box. So if you're going to have a box, you're going to need the left side or the left wall and the right wall. If you have one of them missing, the stuff is just going to spill out and it's not going to really be a box. Okay, so open parenthesis, close parenthesis. Okay, that's it. Now let's go ahead and touch on the different views that the formulas could take and the order of operation. So first, order of operation, this applies to simple formulas, and I'm still sticking right now with simple formulas. The parentheses are going to apply more to complex formulas, but we still need to start with order of operation. Okay. Order of operation, most of you perhaps have already learned and have been given a mnemonic in math. PEMDAS. And you've been told that the P stands for parentheses. The E stands for exponents. The M stands for multiplication. The D stands for division. The A stands for addition. I've got those just slightly flipped there. And the S stands for subtraction. Okay, that is the order in which Google Sheets also operates. Okay, so it follows that order because mathematically we as humans have established that protocol and that rule, so we expect when we see an expression that somebody else is also going to follow that, even if you did it just on paper. Okay, so let's go ahead and take a look at what I mean by applying this rule of PEMDAS. So let me write an expression here. So 2 plus 4 times 4. Okay, if you are to solve this using PEMDAS, are there any parentheses? No. Any exponents? No. Any multiplication? Yes. So that means this operation will happen first. So that means 2 plus 4 times 4 will become 2 plus, what's 4 times 4? Go ahead and think about it. That's right. It's 16. Now that we have that, we can reduce this further. 2 plus 16 is 18. Okay, that's the solution that we get from calculating this expression using PEMDAS. Now, if PEMDAS does not exist, let's see what might happen. I'm going to copy that and paste it over here. Go ahead and follow along here so that you have these notes. No PEMDAS. Okay, let me just align this in the center so that we're not overlapping things. We'll align these as well. Okay, let's do this again. No PEMDAS. We're just going left to right. Forget the rules. 2 plus 4 is 6. So we're going to put a 6, and then we're left with the times 4. 6 times 4 is 24. You have to ask yourself, Do you get the same results in both situations? No, you do not. You get different solutions. If we had done this on paper and you and I, did not agree ahead of time on the order of operations, we would end up with different solutions. If we are working on a chemical experiment, pharmaceutical, or we're trying to build a rocket, send people into space, and we don't agree on the order of operation, we can really cause some major damage, injury, death to people because we were off a couple of inches, pounds, centimeters, meters, because we didn't follow order of operations. Okay, so those rules exist so that we can communicate as humans when we're using mathematics. Okay, so let's go ahead and prove that Google Sheets uses these order of operations. We're going to go ahead and type our equal sign. We're going to go ahead and put the 2 plus 4. So we're typing the same thing that we did up here, times 4, and press enter. And sure enough, we get the 18. So this is proof that Google Sheets is making use of PEMDAS. Let me drop this down this way. And we can go further and show you a longer, more complicated version, but right now this is enough proof, I think, to show you that it's actually adhering to that. The other thing that you saw here is we used multiple operators at this point, right? So we use 2 operators. You can continue chaining this on forever and ever and ever. You could do equals 2 plus 4 times 4 divided by 9 minus 3 times 7, all subtracted from 1,452, right? You can continue building that, and it could keep going on pretty much indefinitely. It would still follow the rules of PEMDAS. You would still find where is there are there any parentheses, exponents, multiplication, division, subtraction, addition, and at the end, subtraction. Okay, just remember I have these 2 flipped. Okay, as long as you don't have the parentheses, we're considering them simple formulas. The moment you begin using parentheses, we cross over into complex formulas. Now that's where things get a little bit more complex. That's why they're complex formulas, because they have multiple parts, but those parts are dictated by the parentheses. That's pretty much it as far as you need to be concerned. All right, so we'll end the clip here. Just understand that with the final clip here on complex formulas, which is kind of all the basics that you need, we will be using parentheses to begin creating complex formulas that can set you free to represent almost the key expressions that you'll need to solve in a spreadsheet to represent real life problems or scenarios.